Hello everyone and welcome back to The Analyst dated 27th of Feb. Today, through this discussion, you will learn about 5 very important current affair topics from UPSC point of view, featured on The Hindu and Indian Express. Our first article is about the dual-use goods and technologies which have led to sanction on an Indian tech firm, also alleged for having close ties with Russian company. So therefore, we will learn about what are dual-use goods and technologies, what regulations are in place for them, and what are the associated challenges. Then, as the Europe's largest economy, Germany plans to enable carbon dioxide storage to fight climate change. We will study about the carbon capture, storage and utilization principles. In the next article, we will cover recent launches made by ISRO, and we will also cover the ambitious projects that have been promised by ISRO. Then we will briefly read about the Permanent Commission and the Indian Coast Guard, as Supreme Court has recently urged the Indian Coast Guard to grant permanent commission to the eligible women. And finally, we will wind up the discussion with newly launched AI model, that is Garbhini, in India for accurate gestational age estimation for our Indian mothers. So let's get started. So hello everyone, and here is the first topic in our hand. This is about the dual use goods and technologies. We are here going to talk about a certain umbrella term which is all encompassing, comprising of certain goods, services, technologies, softwares, etc. which are having dual uses. Before entering into the detail, let's first understand the context. So the context is that central government has entered into examining of an Indian tech firm who has been sanctioned by not only European Union but also by United States for close ties with Russian companies, and there also have been allegations that they were exporting these dual use goods and technologies to US, EU, etc. Okay, why are we reading this? Because it pertains to this part of GS syllabus, specifically corresponding to both GS2 and GS3 part. Now, let's understand what are the dual use goods and technology. As I have already told you, this is an umbrella term. So this umbrella term corresponds for all the kinds of goods, services, softwares and technologies which can be used in two regards. First, for peaceful or civilian purposes, and second, for warlike or military purposes. So products which can be utilized in both these domains are considered as the dual use goods and technologies. And why they are in use? Anyway, before entering into that, let me first explain an example to you. Let's take into consideration a radioactive element. This is the uranium. Now we know that uranium is a very important fuel if we want to do the clean energy transition in our country or globally. So uranium would be useful for creating nuclear energy. It will also help us to develop nuclear medicines, which are again advances in chemical and biotechnology. It will help us to have better food processing. It will help us to have better industrial parametrics as well. But this same fuel is also responsible for creating one of the most powerful and destructive atomic bombs of all the times. In fact, the first ever atomic bomb that was created by Oppenheimer was created out of uranium hydride. So it is also a very potent weapon for the mankind. So can you see that it has got dual use, both peaceful and civilian use and also military use. Next, if you talk about some other chemicals, so for some other chemicals, for example, chlorine, for example, mustard gas, while they are very important for pharmaceutical industry or taking out other industrial operations, it is also very, very harmful because they can also get converted into chemical weapons. In First World War, Germans actually used the chlorine gas and the mustard gas upon the Allied powers. And this was one of the first demonstration of how a chemical, which is actually regarded a beneficial element for the mankind, turned into a very harmful chemical. Next, advances in the computing. For example, we have now got artificial intelligence. Now, it is very important for robusting our economic growth, for improving our security infrastructure, for providing better healthcare, better education facilities, etc. But at the same time, when it goes into the wrong hand, it can also become a very potent element for war or for threatening the securities of the nation. So we have got advanced computing examples like artificial intelligence. We have also got certain cyber tools or certain softwares which are providing encryption. So for example, do you remember the Enigma machine? The Enigma machine that was created during Second World War, and this machine was created by Alan Turing. Alan Turing, who's also regarded as the father of artificial intelligence, because this was for the first time when an advancement in technology, the artificial intelligence, this is considered as the first ever machine of artificial intelligence. This was used to decrypt the codes of the Germans during the Second World War. So we know that again, this technology has got both civilian use and also military use. Then if you talk about the biotechnology, if you talk about the biological agents, for example, certain pathogens and toxins, for example, toxoids, or the vaccines that you create, they are very good. They are very good for even curing diseases, pandemics like COVID. But do you also know that they can also potentially become biological warfare? Some also alleged that coronavirus was nothing but a form of biological warfare only. So we also see that such products are also the dual use goods and technologies. Then we have got aerial technology as well. Now you can see the harmless drones flying, taking pictures, taking photography, doing harmless surveillance, peaceful surveillance, doing mappings of the areas. Now while aerial technologies can provide us immense benefits, they can also be converted into a product of espionage, a mode of espionage, or for in fact bombing as well. You have also examples like intercontinental ballistic missiles, so powerful that it is able to destroy the entire country, and we are developing this as well. So again, when we talk about aerial technology, it is again an example of dual use product. Now, once you have read this, you must have understood one thing, that it becomes immense important for us to manage and regulate them very, very strictly, because we know that it acts as a dual-edged sword. If it enters into wrong hand or into wrong mind, it can be very harmful for the mankind. And therefore, what it requires strict regulations. But then, and in fact, they're heavily regulated across multiple countries, but then still they attract certain challenges. So then what are these challenges? See, the first one is determining the end use. So for example, a particular country exported out the uranium thinking that the recipient country would be using it for nuclear power generation. But lesser did they know that it would be used finally to create some nuclear bomb. So that could be one among the implications, that we do not actually determine the end use. In fact, products like silicon products, for example, some of the critical minerals, they can also be misused vastly. Their end use cannot be predicted because they are used in a variety of spheres, in a variety of domain. Very, very difficult to use that in which particular domain it has been used, whether civilian or for military purposes. Then second, there are complexities in regulations, and this also hinders the ease of doing business for the businesses that are taking up the production of these goods and services. You know that these goods are very important. We need to develop aerial technology, we need to develop certain chemical and biotechnological products. But then what happens for the countries or the companies that are creating it, that they have to face multiple regulatory challenges, especially varied and complex regulatory challenges. Every different country has got different regulations with regards to export and use and regulation of these dual use goods and technologies. So they come into a very complex regulatory environment. It also decreases their ease of doing business, because if a particular company is taking up a production related to these things, they have to go through, first of all, huge, rigid and strict regulations. For example, the drone regulation of India, we have already read in the previous analyst. And you can also take into regard that they will be under the eyes of suspicion of government always, because they are using a dual use good or product. So it also hinders the ease of doing business. Then the rapid technological advances that takes place, the existing regulatory environment is almost never able to catch up with that. So for example, we created certain regulations for missiles that were the main aerial technological advance in 1990s, and then came drones, and we were not having enough regulations for the same. Now we also encompass regulation in the same with the help of MTCR regulation. We'll be reading about MTCR in the next slide. But now that we have regulations for both of them, can't we now evolve our technology into nanobots? Do we have regulation for nanobots? No. So somehow the technology always outspaces the existing regulatory space. So therefore, there are always some regulatory loopholes left here. Then the complex global supply chain. Now, because here we are talking about certain goods which are very, very critical for the economy, very important, but also possess certain hazards, certain risks. it becomes very difficult to track their exact source of origin and source of destination. So for example, if you take into account some electronic good, for example a semiconductor chip, now the semiconductor chip probably would have originated from Vietnam. Now it moves into India, and finally from India it is being used in Sweden, and you would never be able to understand what is the end product created out of it, because it becomes very difficult to track the entire supply chain when it comes to such dual use goods and technologies. So these are some of the challenges faced. Now, what can we do about it, and what are the concluding thoughts? Now we understand that we need to use them responsibly, but at the same time we need to stop their proliferation, and for that we have got multiple international treaties in place. So let's read them in detail because they are very important from UPSC prelims point of view. So the first one is the creation of Nuclear Suppliers Group. Interestingly, this was created after the India conducted the hidden nuclear test. So this Nuclear Supplier Group was created in the year 1974 in response to India's nuclear trial test, where it tries to prohibits or restricts the prohibition of the nuclear technologies and the nuclear inputs, nuclear supplies to the non-NPT countries. What is NPT? Non-Proliferation Treaty. India is not a part of it, and it tries to control the trade of such nuclear technologies into the non-NPT members' hands. So this was Nuclear Supplier Group. Is India a part of Nuclear Supplier Group? No. Do we want to become one? But China always create hindrance in between. So therefore India is not a part. India is not a part of Nuclear Supplier Group. Let's move on to the next regulatory body that we have. This is the Missile Technology Control Regime. Now this particular one tries to reduce or control the proliferation of the missiles and also the drone technology, the unmanned air vehicles, which have the ability to carry the payload of more than 500 kgs. So both these sectors, both these kind of technologies are regulated with the help of MTCR regime. India is a part of MTCR. So India is a part over here. Next is the Australia Group. Now what happened during the Iran-Iraq war, which happened in 1980s to 1988? So Iran tried to bomb them with the chemical weapons, and that was for the first time when it brought the global attention into the menace that can be created by the use of chemical weapons. So once they used the chemical weapons, the Australian group was conducted, and this was created. This is a kind of non-formal group between less than 50 member countries, and this prohibits, this ensures that whatever trade has been done, especially in these dual use goods, they do not get translated into chemical weapons. So this is another regulatory compliance against chemical and biological weapon use of the dual use goods. Then we have got Wassenaar arrangement. Now, is India part of Australia group? Yes, India again is a part of Australian group. Now let's move on to Wassenaar agreement. Wassenaar agreement is basically to share the information among the members of the Wassenaar agreement about the conventional arms that have been traded between them, that have been exchanged, and not just the conventional arm but overall all the dual use goods and technologies. So if any particular statement is asked to you about the regulation of dual use goods and technology, it would be this agreement of Wassenaar. Wassenaar agreement has got its headquarter in Vienna, Austria. And is India a part of it? Absolutely, India is a part of the same. Now, if you talk about India's participation in multiple such regulatory regimes, which is also very important from prelims point of view, let's have a quick recap of everything. First of all, is India part of nuclear non-proliferation treaty for nuclear weapons? So India is not a part of it. Then, is India a part of comprehensive test ban treaty? Again, India is not a part of it. But interestingly, India is a part of partial test ban treaty. So India is a part of PTBT. Is India a part of NSG? No, because any country who is not a part of NPT would be rendered unqualified to join NSG. And that is the argument given by China. So are we a part of NSG? No. Then, if you talk about the MTCR, India is a part of MTCR, absolutely yes. India is a part of Australia group. India is a part of Wassenaar agreement. And India also tries to regulate its dual use exports with the help of a list that it has created. This is known as the SCOMET list, and this word might appear to you in prelims examination and you will be made to identify. So, SCOMET stands for you're using specific or special chemicals, or you are using certain components, organisms, you are using certain equipments, or you're using certain technological devices which have got dual use in them, and they are strictly regulated in the trade domain of India. So you have to get compulsory licenses in order to export them, and you have to regulate to the government duly, and at the same time government has got all the powers to put prohibitions on this SCOMET list. So this is about the regulations in place. Now, what should be the concluding thoughts on this? See, first of all, we understand one thing very clearly, that proper management and proper regulation of the dual use goods and technology is the need of the hour, especially in this time. Now, it's a very critical aspect of not just the national security efforts, for example, India, but also for global security efforts. Then we also need a well regulated approach to ensure that while we understand that there are multiple applications of such dual uses, we cannot really ignore them. They'll be helpful in boosting our economy, in our healthcare, in our employment prospects, etc., renewable energy transition, so many. But at the same time, we need to make sure comprehensively, collectively, and collaboratively that they do not lead to proliferation in the terms of or in the forms of weapons. They do not translate themselves into biological weapon, nuclear weapon, or chemical weapon. Then the need of that finally is to hit or to strike a golden mean where we are balancing our commercial needs, because we understand that we would be requiring such products, but at the same time we have to balance it out with the national and the international security, and striking the right balance would be the correct way forward when it comes to dual use goods and technologies. Now, our next topic is about a very important environmental conservation principle. This is the carbon capture, utilization, and storage, having the acronym CCUS principle. So, what is the context that Europe's largest economy, Germany, plans to enable underground carbon dioxide storage to decarbonize its economy? This is very important from both mains and prelims point of view. You can see the mapping of the syllabus over here. Now, in today's time, what are we trying to do? We are trying to consistently move towards emission-free alternatives. Yes, it will decrease our carbon footprint, but what about the carbon dioxide gases and the greenhouse gases that we have already put up in the air? The solution to this, the answer to this is the carbon capture, utilization, and storage principle. So first of all, let's understand this in detail, that this is a principle which encompasses all the methods and the technologies that will lead to three things. First of all, removing the carbon dioxide from the atmosphere. So first of all, you will be capturing it from the flue gases. Flue gases, those that are emitted from industries and agricultural fields. So first of all, we have to capture the emission or the emitted carbon dioxide or the greenhouse gases. Once we have captured them, then we will put them into recycling, or we will put them into utilization, so that they can be useful in creating certain minerals, or for example certain industrial products or agricultural products, or they can be used in fuels, they can be used to create refrigerants or other building materials, for example slag cements. So we'll be utilizing them, and the rest of which cannot be utilized and is present in excess form, that much carbon dioxide we will be storing safely. Which is also known as carbon sequestration. Do you know which are the best things for carbon sequestration? It is undoubtedly the oceans and the forests that we have. So we have got natural reservoirs for the same. They feed on carbon dioxide, they will be appreciating it, and therefore we need to store them at least in these carbon sequestration tanks. Now, this is the principle of carbon capture, utilization, and storage. But then, what is the need of decarbonization? What is the need of this principle? Now, this evaluation would be very helpful in mains. First of all, there are certain climate commitments, because there is the rampant growth of climate change, as we can see, rampant rise in the global temperatures. And to mitigate the same, all the countries have basically rendered to some climate commitments. These climate commitments are personal to all the countries, and they are named as the nationally determined predetermined contributions. So let's say, for example, this country Germany has committed to achieve the net zero emissions by the year 2045. Now what happens? See, first of all, there is one thing that you are trying to convert green energy infrastructure, fossil energy infrastructure into green energy infrastructure. You are trying to transition. But then what about the air that has already been emitted out in the atmosphere? Or what about the air or the greenhouse gases that are being currently emitted into the atmosphere? You need to take care of the same in order to bring a net zero. So in order to get or fulfill this commitment of net zero, we will try to capture them, store them, utilize them back, and finally sequester them. So first need is to mitigate the climate change. This is also very important because if you can see the chart, you will be able to analyze the shrinking carbon space available for us. We have already set an over-ambitious target of achieving an overall warming to be limited at the rate of 1.5 degrees centigrade. Now, are we in line of this? Not pretty much, because if you analyze the carbon space available, if we wanted to limit the overall annual temperature or the global temperature rise from the pre-industrial levels, that is 1750s, up to present, if we wanted to limit it to, let's say, 2 degrees centigrade, we would have got some this much quarter, let's say 1/3 quarter of the carbon space available with us. But if we move more ambitiously towards 1.5 degrees centigrade, then we are left with very, very less carbon space, which means we cannot afford to emit a lot of greenhouse gases right now. Therefore, we need to stop the emissions itself and not just create different alternatives. Now, because we want to achieve net zero emissions, and we also want to achieve net negative emissions, where we are emitting less and sequestering more. So therefore, all of this would only be done with the help of this principle. And second, there are certain hard to abate sectors as well. There are certain sectors which we cannot stop at the current moment. For example, sectors which are creating cement or steel for us. We cannot stop their production, but the best we can do is to stop their emissions from entering into the atmosphere. How to do that? By again deploying the CCUS principles in these sectors. For example, the coal sector again, because if you talk about the power generation, still majority of the power generation that is there in the world is coming from thermal power plants or are driven by fossil fuels. So we cannot wind them up, we cannot phase them out currently or like within 1 year or 2 years. So what we need to do, we need to retrofit them at least, so that we try to put up zero emissions, we try to absorb their emissions so that they don't go out into the atmosphere, and at least till we do not completely transition into the greener alternatives. At least this much we need to do. And for that again, which principle would be helpful? The CCUS principle. Then it will be having immense economic benefits. As we've already told that there is an element of utilization as well. Carbon dioxide itself is a very useful chemical, a very useful gas as such. If you will be using it, for example, in the depleted oil fields, if you pressure down this gas into the depleted oil field, it will try to bring up the oil with the help of the pressure exerted by this gas. So this will help us in efficient oil exploration. That's the first thing, and it is already utilized by ONGC and Indian Oil Corporation in India. Then we can also produce green hydrogen with the help of carbon capturing. So if you talk about the generation of hydrogen, which is very important for driving the energy transition right now, it is mostly derived from, or it is mostly coming in the form of dark or brown hydrogen. Why? Because mostly it is coming as a result of decomposition of methane that we are getting from the fossil fuels. So because of the burning of the coal or because of burning of some fossil fuels, and when it gets oxidized, it leads to carbon dioxide and hydrogen. Yes, you have achieved hydrogen production, but at the same time, the byproduct is carbon dioxide. And if I sequester this, if I collect it, capture it, and utilize it somewhere else, then what I'm doing, I'm converting this dark or brown hydrogen into blue hydrogen. We have already read about multiple forms of hydrogen in the previous Analyst. You can always have a look. So there are multiple types of hydrogen, and this will help us create more greener or more cleaner hydrogen. Then it will also help us to boost the crop growth, because crop loves carbon dioxide. They are the best sequesters of carbon dioxide. So we can pump it down into the forested areas and they will be utilized well. They will be also helpful in fertilizing or boosting the productivity and fertility of the crops. Then we can also create certain industrial products using the same. So we know that industrial, for example, the cement industry is a menace. So how can we create more environmental friendly cement? By mixing the carbon dioxide with the steel slag, and this will help us to create more biodegradable kind of cement, and this is also having lesser carbon footprint. This is also going to help you in building multiple mineral carbonates, because as you know that carbon dioxide can react with multiple minerals, for example magnesium, and it will be creating magnesium carbonate. So you will be also able to create multiple useful minerals like calcium carbonate, again with the help of carbon dioxide. So it can be utilized, and therefore it will be very influential in providing economic boost or economic benefits to the country. Now, there are certain best practices that I want you to take home, because they can be again used in your answer writing. They can also be used, and they can be given in the form of a question in prelims. So first of all, we have the example of a Scandinavian nation, Norway, which is having best of the HDI and is one of the happiest countries of the world, is also in its way to become a pioneer in carbon sequestration by building world's first large-scale carbon dioxide transport and storage infrastructure project, which is known as Longship. So you can provide this case study in your geography answers. Then the next example is UK. UK is also trying to transport the carbon dioxide and develop the storage projects, and this project name is the Northern Lights project. Northern Lights because it is again trying to push it down into the Northern Sea. Northern Sea, which is also having very rich oil reserves in them. So here we are trying to put it into the Northern Sea. Then the example of Denmark was given in this particular article which was featured today. So it is also trying to bury the excess carbon dioxide beneath the North Sea. So you can quote some of these examples in your mains answers, and these are the best practices from which even India should learn something from. Now in the next topic, we will have a quick wind up and assessment of all the major space ambitions that have been taken up by the ISRO in last year, as well as what it's trying to do in the upcoming years. So we will evaluate it because recently ISRO's chief has spelled out his aspirations to land Indian on moon by 2040. So first of all, see, we are going to talk about Chandrayaan 3, we are going to talk about Gaganyaan, we are going to talk about XPOSAT, which has been recently launched, in fact in the new year itself, and then we are also trying to see whether India will be able to collaborate with Japan in order to bring Indians on moon. So first of all, we will talk about Chandrayaan 3, which was the most important mission taken up by ISRO. And this is where ISRO launched it on 14th of July, and it finally landed the desired site, targeted site on the moon in the very next month in August. Now Chandrayaan 3 makes us the fourth country in the world to achieve a particular feat. This particular feat is to have soft landing or a very controlled maneuvered landing on the surface of the moon with a very high precision. So the crater that we were aiming, we were able to drop ourselves very nearby to it. So there was a kind of precision landing, at the same time controlled landing that was done, and this is known as soft landing. This was actually ISRO's second attempt and the first successful attempt to have soft landing on the surface of the moon. And obviously after Russia, USA, China, we become the fourth country to do the same. And now recently Japan, with the help of SLIM mission, has also established itself in this league of the countries who have performed successful soft landing on the moon. Now, what was the launcher deployed over here? This was a geostationary launching vehicle. This is a GSLV LVM3. Do not confuse it, because this is the same GSLV Mark III that we used to read, having 3 stages. The upper cryogenic stage, the very same launching vehicle was used. It comprised of 3 modules. One was the propulsion module, which would take everything up, and then there was lander module, and then there was a rover module which was attached on this lander module. So if you talk about the propulsion module, it carried 2 things. First of all, the lander module and rover attached together, and second, the shape module. The shape module, or also known as the spectropolarimetry of habitable planet Earth, it was basically to understand the signatures of the habitable planet Earth in a particular wavelength, assess the same. So just understand, two payloads were carried by the propulsion module, that which is responsible for taking it to the site. Now, when it got dropped into the site, what dropped? The lander module. Lander module landed, and lander had multiple payloads. It basically had three of them. There was Rambha payload, also known as the Langmuir probe. This payload is very important. It is basically to measure the plasma that is present on the moon's surface. Plasma is the fourth form of matter in which the ions exist freely, or the matter exists in ionized form at very high temperature. Then there was CHASTE. CHASTE was responsible for measuring the thermal properties of the lunar surface, and the third payload that the lander carried was ILSA. It was to have the geophysical studies, for example, studying the seismic activity that could happen on the surface of the moon. Now, once the lander has dropped, then it will further drop away the rover. Rover is a kind of autonomous bot. Now, the bot will be having two payloads. It will be having assessment payload to assess the X-ray spectrometer or the alpha particles present in the moon, and laser-induced breakdown spectroscope to understand the mineralogy, or basically the geology of the moon again. So these are the following payloads. If you calculate them, 1, 2, 3, 4, 5, 6, total 6 payloads were there. And in this year's Haryana PCS, the total number of payloads deployed in Chandrayaan 3 was also asked, was one of the question. So therefore I thought I might tell you the same. Now, if you talk about the lifespan of this entire mission, it was only of one lunar day. But one lunar day doesn't mean one Earth day. It means about 15 Earth days. Now, let's talk about the Gaganyaan mission, where India is trying to get its feet to develop first manned mission, or the first ever human space flight. So this is going to be a 3-day, 3-membered manned mission. And where are we going to go? We are going to deploy ourselves at about 400 kilometers up above the Earth. This is the low Earth orbit, in the low Earth orbit. So it is going to be launched by, again, the same one, GSLV Mark 3, now renamed as LVM3. And it will be having 2 unmanned missions before we are actually deploying our manned mission in order to assess the security and safety. So there will be 2 unmanned missions. In these unmanned missions, it will carry a humanoid or an autonomous bot. This female humanoid bot is known as Vyomitra. It will be carried in Gaganyaan, so it is a part of Gaganyaan again. Again, a question which can be asked in many examinations. And then with this, India becomes a 4th nation to discover or to explore and try to venture into human space flight capabilities. Again, the previous ones are Russia, US and China, and India will be becoming the 4th one. If you talk about the entire process of the Gaganyaan, so Gaganyaan will be having 2 modules. One will be the orbital module. The orbital module will be having 2 modules. So if this is orbital module, it will be having one crew module and one will be service module. So when for the 3 days, this entire module is situated in the low Earth orbit, the service module would be augmenting and helping the crew module which is carrying 3 crew members. Then after that, it will be aborted. Both of them will get separated. As you can see, separation of the crew module and the separation and the service module will happen once we are ending the flight. And then the aero braking will be done and parachutes will be deployed on the crew module so that they can be pad aborted, or they can be safely landed back to the surface of the Earth. So this is the idea of Gaganyaan. Gaganyaan is stipulated to be launched in 2025, but this year is not very important because it keeps changing. Okay, now the next mission that India launched, or ISRO launched on 1st of January, and it was actually covered very well in 2nd January's Analyst, was XPOSat. So XPOSat is an X-ray based polarimetric satellite, and it makes India second in the world to create a satellite of this kind, where we be trying to understand the polarization of the X-rays that are coming from the cosmics or the celestial universe. So here what we are going to do, first of all, it was launched not by the GSLV but by the PSLV, and it is again going to be deployed in the low Earth orbit at a height of somewhere about 650 kilometers with a certain inclination, so that we see a particular, so that we are able to see the particular neutron stars or the escape that they are taking at all the times. So that is the thing. Mission life is 5 years and it will be carrying 2 payloads, again one of a kind, first time to be built with this kind of frequency in the entire world. The first payload is Indian X-ray polarimeter, and the second one is for developing more higher resolution for whatever you're trying to capture. So this is the X-ray spectroscopy and timing module. This is again for higher resolution, a kind of camera, and this is a polarimeter which will be able to calculate the inclination brought in by multiple celestial objects in the incoming X-ray. So what happens if you talk about, let's say, very gigantic celestial objects, for example black hole, then because they have such a high energy, they will be radiating energies again of very high frequency. So energies of high frequencies are known as X-rays. But what happens, for instance, this is a black hole and this is the Earth. By the time they emit the X-rays, by the time they come across multiple other gigantic forces, for example let's say a neutron star, or for example another black hole, or for example another galaxy, the light wave that is coming or the X-rays that are coming, they become polarized or oriented in a particular direction. So now it will be oriented, let's say, in this direction. Then it will be oriented via another black hole in this direction. So when it reaches the Earth, we will be able to assess its entire travel with the help of final inclinations that this X-ray has possessed. And so therefore we will be deploying a kind of telescope which will be able to calculate this inclination which has happened in the X-rays. So this will help us to discover about the neutron stars, their patterns, the black holes, the magnetars. All of this can be assessed very easily. And last but not the least, a dual mission which is still under process. This is the Chandrayaan-4 mission, also known as the LUPEX mission. LUPEX mission stands for Lunar Polar Exploration Mission, and it is kind of a joint venture between the two space giants, ISRO and JAXA, that is India and Japan. So we have already seen that India has already demonstrated its capability using Chandrayaan-3. So it had got 3 modules and it was very successful in performing soft landing. And we were appreciated worldwide for the same. Now again came the SLIM. SLIM also got launched and it was launched by JAXA. This was also their second successful attempt after the first failed attempt, similar to Chandrayaan-3. So this is the SLIM mission by JAXA, which deployed 2 rovers successfully on the surface of the moon. So now what we collectively want to do is harness each other's best points together and then enter and venture into the very difficult south pole of the moon. So we will be trying to study the south pole of the moon, where India will be providing lander or the soft landing capacities, and the Japan or JAXA would be providing rovers. And the stipulated time of this mission is about 2025, but again you don't need to remember this particular year because it keeps changing, and since India has already made declaration that it would be done in 2040, so we are not sure of the exact date when this mission will see the light of the day. But anyway, this is about the LUPEX mission which is going to be together of India and Japan. Now our next topic is about permanent commission in the Indian Armed Forces, and this has been in news because yesterday Supreme Court urged the Indian Coast Guard to ensure that the eligible women are granted the permanent commission. So the first question should come to your mind, what is permanent commission and why is Indian Coast Guard not providing it the same, and are the Indian women actually allowed to get the permanent commissioning in armed forces or not? All of these questions will be answered in this discussion. So first of all, let's understand what is permanent commission. Permanent commission is that option which is given to a person working in the armed forces to exercise or to carry out their careers until retirement. Now this particular option of permanent commission for the longest of time was only available to the men. So they used to get the permanent commissioning after completion of their short service commissions. That is, after the completion of 10 years, they got the option of either retiring voluntarily, they can be commissioned permanently into the services. But this was not for the case of women. When it comes to women, first of all, they were only allowed the access of army in the form of short service commissions. Short service commission meaning that they will be entitled to the services for 10 years, which can be extended up to 4 years, meaning they can only work for up to 14 years, not more than that. Because after that, they do not have the option of exercising permanent commission or getting permanent commission. Now, of course, this was challenged by many brave women. And so, what happened? First of all, let's understand what are the issues related to the permanent commission. See, first of all, there is a lack of permanent commission for the women. And second, it also restricted their service duration. They can only work for up to 14 years. Now, because if they are only able to work for 14 years, they will never be upgraded up to the top tier ranks or to the higher or the upper ranks. For example, the colonel, lieutenant governor, lieutenant general. So therefore, they will never be actually able to upgrade themselves to a higher level, the levels of colonel or lieutenant general. So colonel promotion and eligibility, all of that also became challenge for them, because in order to become a colonel in Indian armed forces, you need to have at least an experience of 14 to 16 years. But in the case of women, they are only allowed to exercise or to be in the service for only 14 years. Then it renders them ineligible. So that was one of the concern. So finally, some women came up front, and a case was made in front of Delhi High Court by the name of Jasmine Kaur versus Union of India. And this is for the first time, this case was running since 2006, and this was for the first time in 2009, when a particular Indian armed force, that is the Indian Air Force, for the first time allowed to grant permanent commission to the SSC affiliated women. So this was a very welcoming step. And then finally, what is the status of women today? Are they allowed to have permanent commission in the Indian Armed Forces? Absolutely yes, because Supreme Court in its judgment of 2020 granted permission to get the permanent commission to all the women officers with even retrospective effect as well. And this will finally break the glass ceiling for them to rise into higher rungs or higher ranks in the military or in the army. Now, let's talk about Indian Coast Guard, where it is still not practiced. So, it is currently being practiced. You would have also seen the Republic Day parade. It showed exemplary performance by all the women leaders who were in the higher ranks and commands. But it is still compromised in the case of the fourth armed force, that is the Indian Coast Guard. If you talk about the overall army structure of India, the Indian armed forces are comprising of four broad uniformed forces. One is the Indian Army, then there is Navy, then there is Air Force, and then there is Indian Coast Guard. Indian Air Force was the first to grant the permanent commission. Navy and Army also gave it subsequently, but one which is lagging behind is the Indian Coast Guard. Now then, what is the role of Indian Coast Guard? Indian Coast Guard is responsible for protecting the maritime interest of the India and imposing the maritime laws, or also known as the admiralty laws in the country. So what is the domain of jurisdiction? Where do they actually work? They work in the coast. They work in territorial waters of India, in the contiguous zone, and in the exclusive economic zone. This is their underlying jurisdiction. If I map it out, then if this is the shoreline, let's consider that this is the baseline of India. And from this baseline, if I calculate up to 12 nautical miles, then this entire water till 12 nautical mile would be considered as my territorial water. If I move 12 nautical miles ahead of this, then all the water from baseline this would be 24 nautical mile, and all the water in this area is the contiguous zone. And if I move about, let's say if I move 200 nautical miles from the baseline, then I will be getting what? The exclusive economic zone. And all of this is the jurisdiction of our Indian Coast Guard, which was also formally established only in the year 1978. So in this discussion, we read about the permanent commission, what is the entitlement of women in the permanent commission across the Indian Armed Forces, and we specifically talked about the Indian Coast Guard. Diving into our last topic, this is the Garbhini GA2. In short, the context is that researchers of India have developed an indigenous AI-based model in order to correctly determine the gestational age of the fetus in the later parts of the pregnancy, which is in the second and the third trimesters of the pregnancy, which is often one of the most difficult or one of the most challenging reproductive problems of India. So in short, Garbhini model is an indigenously developed AI model which tries to solve a very important problem going on in the reproductive sphere of the Indian healthcare. And this is to rightfully and accurately measure the age of the fetus, especially if a pregnant woman has came to determine the same in the later stages of pregnancy. What is the exact problem going on in the Indian healthcare right now? First of all, the societal problem that most of the pregnant mothers come at a very later stage for diagnostics. Probably they have entered the second trimester or the third trimester. When they come late, then they are also late for the ultrasound, and it also becomes very difficult to diagnose their exact date of conceivement or exact date of pregnancy. That becomes very difficult. Now what do the doctor do? Doctor would be deploying some of the prediction models. The problem with these prediction models like Hadlock and Intergrowth are that they are based on Western sample data, the Western mothers or the Western population. Now, as we know that the growth of fetus in an Indian body and in a Western person's body is very, very different. Therefore, these models are having high levels of error rate. And when you are trying to deploy such models, there will be particular implications as well. For example, you will not be able to take proper maternal care or proper fetal care at the right time. Second, it will also lead to premature birth across the India, because probably the estimated fetal age was not the accurate age. Probably we thought that fetus is of 3 month old while it was only 2 month old, or while it was only 1 month old. So these issues have got, these errors can have multiple implications on the health of both the mother and the child. In order to improvise on this, we have to create a customized AI model which is taking the data not from the Western sample but from the Indian sample only. And therefore this is a very promising advent in the field of medical science, or in the field of specifically reproductive medical science. So this is developed by the researchers of multiple institute, as you can see from here, and it has got funding from other different institutes. As you can see, Department of Biotechnology, and there's BIRAC, there are multiple again schemes. I have not written all of them because that's not very important. What is important is which problem it tries to solve. You understand the problem. Now what are the solution that it's presenting to you? First of all, it figures out the exact age of a developing fetus in pregnant Indian women during the later part of the pregnancies, that is during the second and the third trimester. And the kind of sample that they are taking is very relevant to Indian population, because the sample is derived from the pregnant mothers of North India. And therefore, if you see the acronym of Garbhini, you will be seeing INI. This INI, this NI stands for North India, because the sample has been taken from the North Indian mothers. And that too, about 2000 ultrasound scans have been taken, inputted into the machines, and utilizing the principles of machine learning, it has created certain AI models to predict the same for the rest of the Indian population. This is the idea of Garbhini. The best thing is, it has actually reduced the error rate of prediction up to 3 times as that was seen using the Western models. So this was all about Garbhini. I hope you have learned something from today. Thank you so much for your time and have a nice day.